guys, again, I'll be moderating this session, so we have a lot of amazing questions that can help, again, all the folks who are here probably building their models or deploying their AI models. So we'll quickly start with Eliot first, right? So Eliot, I think since Photo Room has been such a pioneer in AI, wanted to start with the question that would you elaborate on genesis of like machine learning at Photo Room? How did it all start? How did you build the initial strategy, and how did you deploy like the first model?
Yes, thank you very much for your question and thank you for having me. At the beginning, we were using a very simple open source model. So I think it was DeepLab v3. And this was the first model we could get our hands on that was able to segment images. And then with time, we refined it more and more. So I think after this, it went to a simple UNet, then an architecture called U2net. And we evolved since then to a more modern architecture. So we're using a mix of techniques, including transformers, but those are custom models that we design ourselves and train ourselves from scratch. So yeah, it went from open source to very custom and yeah, custom architecture.
Got it. That's pretty interesting, and yeah, sounds very iterative. Awesome. So next is for Saravana. Again, I wanted to understand, especially in terms of like Apollo, in the world of like hyper personalization, right? How do you like contrast between like efficiency of like fine tuning versus having prompt engineering, like especially in the context of large language models, right? When do you use what? Like, how do you go about it?
Right. Yeah. Is the volume okay? I guess the operating word that determines what you go for is how definitive your task is, right? Like in any AI pod application, you have tasks on multiple ends of the spectrum in terms of how definitive that is. So the more definitive your task is, the more control you need in terms of what your model does, right? So I'll give you an example that probably helps think about this better, right? So we build, say, an email classification that categorizes into like 12 different categories, right? And these categories are nothing unique, right? You have like a clear definition in terms of what the categories are, and these language models do understand what these categories are all about, right? The beauty is that with the state that we have today, you'll be able to, with minimal prompt engineering, you'll be able to get like 85% of accuracy right off the bat, which is amazing, something that's unthinkable like 2 years, 3 years ago. But an email classification that works like 85% of the time is not good for any product that you build a workflow on, right? Imagine like Gmail spam filter is like only 80%, 85% accurate all the time. So to go past that barrier is when fine tuning becomes extremely critical. And there's also the other dimension in terms of performance, right? So again, the models like GPT 3.5 and 4 are great, but users are not going to be waiting for like 30 seconds for your application to produce an output, right? They're not going to be as forgiving as what they typically are inside when they go to ChatGPT. So with fine-tuning models, you can always go for, say, much smaller models that gives you pretty close to in terms of what your model performance is, with the fractional amount of training data set as well. Again, today it would take about like 1/10 of training data that probably took about like 2 years ago, right? From BERT to say digital BERT to say GPT, your training data set requirement is becoming smaller and smaller, and we're also like culminating at like few short prompts. So yes, so the more control that you want, then of course you need, say, fine tuning, and there are of course pure generative AI use cases where you need, say, a bit of creativity, you need a bit of flexibility in terms of what your model generates. So that, I'd say, is kind of the big dividing factor.
Got it. No, that's super helpful, especially to understand like for latency, you always like would prefer like a fine-tuned model, whereas like if it's more general purpose and they're like not hardcore limits on like the compute and the latency, right? That's when like prompt works pretty good, right? For new use case. No, that's really good. So yeah, next would love to hear from Prasenjit again. Like as AI becomes a part of like our everyday life, right? How do you guys like while developing models balance between creativity and accuracy, and especially in the context of your specific industry? If you could help us enlighten that part.
Yeah, that's a very interesting question, and this is something we struggle every day because we work in the field of education. We are the first company which introduced AI voice assistant in the classroom. So we have been dealing with that problem, especially on now with the whole generation side, right? Generative AI, that what do we want the classroom interaction with such a such large language model should be. Should it be creativity? Should it be helpfulness? Should it be harmlessness? Right? All these different questions, right, are there. So there's one side of the house, or at least the teachers, who think that we have to be accurate, we have to be grounded. You cannot let anything toxic or anything that's inappropriate that come up, right? And there are some other teachers who feel that it's okay, I can handle that in the classroom if something of that sort happens, but you need to have that freedom for kids to get something beyond what you. So it should not be like cut and dry. It should be something more interesting, right? And so what we are doing are a couple of things, right? So one is definitely, right, the fine tuning and corpus groundedness is very important for us. So we are looking at a lot of retrieval based generation, right? Is because one of the most important thing in education is the curriculum, grade levels, all of these are extremely important. So Wikipedia content doesn't help. In, if you tell a teacher that, oh, I'm going to teach some or give something from Wikipedia, the teacher will say, okay, I don't need that. So for us, the first realization was that teachers don't like Wikipedia for teaching content. You can of course use it in the at home, but not necessarily in the classroom. So which means that we have a corpus of curriculum, and this is like all across the world, right? So right now we are mostly focused in US, but even in US there are like 52 different states, right, which have all their different curriculum, whether it's for science, ELA, all of that, and of course then you have many other curriculum around the world, right? So one of the approach we are taking is that yes, we will ground it in corpus so that it's a it's grade leveled, it's curriculum aligned, all of that, right? First of all. The second is that we want to make sure that the model is tamed enough, because safety is of utmost importance. If anything happens due to these models to to the children, right, we are liable. So for us, the LLM part is actually a very small part of the larger system that we need to actually keep these models tame. And hence we worry a lot about safety, we worry a lot about the fact that where the content is coming from, we worry a lot about the fact that when we talk about grade leveling, do we really understand what is grade leveling, right, for these LLMs? So for us, it's really in these choices, and some of these are, I don't say there's any science to it. Most of it is empirical right now that we hear. We constantly work with teachers. We try to understand what they want, and we try to do the best we can. But I don't think we have yet defined a way, a science to it, by saying that this is what exactly we do to ensure that, how do you balance creativity versus the informativeness of such a thing.
Got it. And is philosophy also going to be a dimension in that now, understanding from your question? How do you want philosophy childs to be raised? Yeah.
It's true. Yeah, I mean, it's a tough question, right?
No worries, no worries. We'll probably circle back to that. Okay, so coming again back to Eliot, right? So, especially talking about the data acquisition part in machine learning model development, right? So, let's take a particular example. Let's say for object detection or background removal, right? So let's say once you transform from an open source to building your custom model, right? How did you go about like building the data sets? How tough was it? And how, if you could suggest some ways in which we can like make it faster? Yeah.
Yeah, that's definitely a tough topic. At Photoroom, we use two things. We used a mix of synthetic data and annotated data. So for the synthetic part, it was generated using 3D software, and it allowed us to get really accurate annotations. They were basically pixel perfect. The downside of synthetic data is that it's not really real world accurate. So there are ways to work around that, but if you only train on synthetic data, usually your model will not fare well in the real world. So that's why we also have annotated real world data. And for this, we worked with annotators at the beginning. And it was really tough because we need really pixel perfect mask, and it's not easy to get, especially if you have a soft pixel like hair. Okay, is it part of the foreground? Is it part of the background? That can be really hard. And talking with people in the industries, even getting annotators to agree with each other on what is the foreground, what is the background, is really, really, really hard. Something we developed a bit later at Photorum is interactive segmentation. So as a user, you're able to say, okay, I want to keep this part of the image, but remove that part. To give you an example, if you have shoes that are standing on a shoebox, well, do you want the shoebox, both of them, or just the shoebox, just the shoe? And as a user, I can, okay, click on the shoe, click on the shoebox, and it will keep both of them. And this is something we developed at first for our users, but we quickly realized that we could use this model for annotation. So we partner with annotation agencies, and they were using our own models, and we're clicking on the image. Okay, this is part of the foreground, this is part of the foreground, this is part of the background. And so it started sort of a flywheel effect of, okay, thanks to our models, we could improve the data sets. We had better data sets, so we could have better models, and so on and so forth. And this is something that was really, really, really helpful. Now, when it comes to how to make it faster, there's no secret recipe. Today, you can see that with the likes of for instance, segment anything from Facebook, they still went through an annotation process. So I think they have more than 1 million images that were annotated by a company. So besides maybe self-supervised learning, which really can increase the quality of your model by pre-training on a large unannotated subset of images. Besides this, there's no secret recipe to get really, really fast, high quality data.
Got it, got it. And in terms of like synthetic versus real data, so what was your split for like that? And like, did you experiment with the split, which gave you like a good accuracy, like for people?
For us, there was no specific split that worked well. However, what worked really well was to have the synthetic data focusing on edge cases that would have been really hard to annotate. So, for instance, if you go for images with a lot of holes or like a lot of hairs, this is the kind of things where synthetic data really shines, because if you had to annotate it yourself, it would have been really, really hard. So this is the kind of really, really helpful areas where not having to annotate images is really, really helpful. But we didn't find a magic split that was working for us. What doesn't work at all is exclusively using synthetic data. That's for sure was something that's not working when it comes to using it in the real world.
No, that's a very interesting learning, and I think people can also benefit like in the crowd from that. Yeah. Cool. Again, to Saravana again. So again in the pursuit of hyper personalization, right? Do you see, especially for Apollo, like there are more like customer specific models which like get trained for every customers, or do you see this more on a industry level now, whereas let's say for like sales processes or any like data, right? And how do you see the cost implication of like having very customer specific strategies?
Yeah, it's hard to figure out in terms of what works until you try things out, right? So if you look at the whole model hierarchy, so at the top you have these global models that are trained on, say, an entire web corpus, that model that knows about everything. Then you have this industry specific model similar to, say, Bloomberg GPT, which is targeted towards a particular domain. Then you have use case specific models, right? That is geared towards getting like one use case really well. Then you have, hey, how can you actually make this really work well for customers? So looking at, say, industry specific models, it is not going to be a common occurrence where you get, say, a data subset that is still large enough, right, compared to, say, web, that is your exclusive mode that you can actually train a model on, right? Bloomberg GPT is going to be an exception. As someone who's actually worked in Bloomberg sometime back, they do actually have, say, years and years of, say, decades of financial data that they can train on, which makes sense. Then you'll have like pockets of like industries like, say, bioinformatics and whatnot, that is going to be geared towards very specific use case. So in terms of some cases where you can train your own foundational model that is going to be comparable to, say, web or even better than web, is not going to be a common occurrence. You'll see pockets of things happening here and there. So the biggest explosion what you'll see in companies like Apollo and almost any company which actually has to build an application that uses at the end of the day, is that you'll have at least like 15 to 20 models. crazy ballpark number, right, of models that are working in synchronous, right, and synchronity in terms of producing this final user experience. So I see a lot of explosion that is happening on that space. When we come to the customer centric model, the big challenge that we have is of course the scale, right? So even if we consider all say the upper strata of paying customers for upload, you're looking at like 30,000 companies, right? That's a lot of models to actually host, right? I think we'll be spending way more than saying what every single customer is actually paying us. So the question is, how do you actually make that work? So there are a few factors that goes in, right? So one is when you think about customer specific model, your turnaround time for updating these models is going to be near real time, right? And when a customer actually goes and like, you know, he performs an action, you want the feedback almost right away, right? And the traditional model setup is not going to let you like train in a matter of hours, right? Especially when you think about like such large scale of models. So that is one big challenge. And the second challenge is when you think about enterprises, by definition, there's no enterprise that does not have ACL on top of every single slice of data that they have, right? So one innovation that we are hoping to happen soon is like language model that understands what the data boundary is, what data that can expose to a particular user versus some that you cannot, right? I think when you think about web, it's public data. I think that's a problem that the industry has not really grappled with. When you think about enterprise, data security becomes immensely crucial. So again, what I see in the next year and a year and a half in terms of what companies like Upload is going to do is more and more in terms of can you do a lot of these fine tuning and can we do a lot of in terms of feeding customer context as input to these models, right? Because this context comes across multiple channels. If you think of Upload, right, so like so many different channels in which you can get insights. You understand what is happening in say all the meetings, all the Zoom calls, there are emails, which customer eventually buys say, a product versus someone who's not, like so many contexts that's coming in from multiple sources. So we'll see more and more in terms of model that are actually using these output of other models that's using as an input, and there's going to be an inference engine that's going to be sitting on top that's going to give you recommendations in terms of what to do next, what you can do better, what to avoid, and all those things. So yeah, I see an explosion in terms of use case specific models. I see an explosion in terms of smaller models that is producing output for something to be consumed on top, similar to say the classical what say the paradigm was in terms of what an actual production ML system looks like. In terms of industry specific cases, there are cases where of course we will see, but the question is, do you have say like a large size corpus that is specialized in a way that it is actually going to make a difference? I think that's something we don't have a lot of success stories yet. Again, even in terms of Bloomberg GPT, we don't know what the success story is yet is. So yeah, that is, I'd say, TBD.
Got it. No, that's super helpful. Cool. No, that's helpful to understand like customer specific and like how task specific models can be, like how you can maybe make it more customer specific by just doing some prompt engineering there, right? Okay, switching to Prasenjit, and this is a very interesting question, right? So again, you guys are one of the few companies that are building like their foundational models from scratch, right? So can you just highlight the process and what are the potential challenges like that you're facing, like when you have to build like machine learning models from scratch?
Yep. Yeah, it's a great question, and again, I always say, right, finance, healthcare, and education are going to be a slightly different industry in the sense that they affect people directly, right? In the sense of life, money, and children, of course, all precious to us, right? So, so we're extremely, aware of that, and hence the models that we are. So the path we took was that, and to Saravana's point, right, that not for the foundational models, right, are not something that you just start doing, on a whim, right? It's something you have to seriously think, because at least for us as a startup, right, I mean, we have to seriously think whether I can spend $10 million running for 60 days, right? I guess that was what Falcon took, right? So so for us, those are big decisions, right? So the path we took was that let's start being part of the open source. So we leveraged a lot of the open source model, but we got very serious in terms of fine tuning, right? In terms of the quality of the data. And I think all of us are increasingly seeing that data is back in fashion, right? So if you remember the whole the technical debt paper, right? I think 2015, the model was really this small part of the whole thing, right? And this is exactly what we are seeing, at least for our industry, that yes, model is important, the kind of architecture you're using, but it's going to become increasingly important to have good quality data, quantity of data we all know by all the scaling laws, right? And also the fact that the guardrails that are around, right, for this model to function in the way that you want, right? So for us, the path right now is mostly been very careful fine tuning. We are building our own corpus from the open source, and most likely we'll also release some of those data sets, right? We are also tweaking some of the models, which we also plan to release in the open source sometime. And also, we are very seriously looking at the corpus grounded information, retrieval based generation. And there, one of the things we realized is that actually retrieval based generation is not trivial, because when you are pulling pieces of text, right, from a vector database, and you're then giving the LLM for it to compose a consistent piece of text, it's actually a reasoning job. It's not as trivial. So hence, one of the realization we had that it's just, 20, 30 billion parameters may not be able to, parameter models may not be able to do the job, because reasoning, chain of thought, all of that arrives slightly later, and we have seen many of those work, right, saying that it slightly happens at a slightly higher number of parameters. So these are things, right, we are kind of juggling with at the moment, but we are not thinking of pre-training a model, right, really as a foundation model. So that's something maybe slightly in the future, so that we stay afloat to be able to do that.
No, that makes total sense. Yeah. Cool. Okay. Now again, coming back to Eliot. So again, just wanted to understand, like, especially in a case of like fine-tuning scenarios, right? Where like when you're transitioning, let's say, from a open source model to a bespoke model, right, which is like fine-tuned. So what are the factors, and when do you like actually trigger that, and like what influences the decision of, yeah, now we can go to our own like bespoke model?
Yeah, so at the very beginning, we always try to look at existing open source solutions, and it's the field is moving extremely fast. So even if you start working on a model for a while, someone from a lab might be able to come up with an open source model that's much better than where you are. So you always have to be looking at the existing solutions. However, usually we start to put an open source on an available model in production, and we start to gather feedback from our users. So whether it be through the live chat in the app or just emails that people send us, and they tell us about the limitations of the models. So, like, to give you an example, when we work with classifiers to try to guess what's in an image, our first models were using just the classic open source classifiers you can find online, and they were very often mistaken between, for instance, people and dolls, like the Barbie dolls you can find in many on many shops. So, and this is one of the examples that in Photoroom we provide you filters that are different if it's an object or if it's a person. And the users were really confused because their Barbie dolls were classified as a human. So they were like, okay, yeah, but those filters, they don't really apply to those objects. We want something else. So that's one of the examples where you realize that, okay, this use case that made sense for a regular classifier that you can find online doesn't necessarily make sense for our app. And this is where we need to go custom and either change the data, fine tune the model, or train a model from scratch, because those use cases don't really align with what we need today. So that's the general reasoning that will push us to train custom models. Another example is if quality is not there. It's simply that if the controls of segmentation is not good enough, if it doesn't segment hair well enough, well, that's another reason to go with a custom model and go beyond what's being offered online and what's available in the open source models. And of course, what this will trickle down into is the differentiator with your competition. If everyone is using open source model, of course, and you're using a very good custom model that's very good in your niche, well, people will prefer using your app. So that's another very good reason to switch to custom models.
Got it. So is that like mostly like customer driven, or are there like scenarios where sometimes it's internally driven also? Like we need to be maybe better at background removal, or we need to be the best company in doing a particular kind of a thing? Is it like
The task specific feedback is usually user driven, but for us at Photoroom from the very beginning, we wanted to be the very best at background removal. So it made sense to us to just from the beginning say, okay, we are going to dedicate a lot of resources and time to be the very best at this specific task, because this is the core of the app. When you put an image in Photoroom, we immediately remove the background. So the experience must be really, really smooth and accurate. So yeah, this second part was mostly driven by business reasons. We want to be the very best at background removal.
got it? No, that's super interesting to understand. Yeah. Cool. Again, moving back to Saravana. So again, so especially in terms of like Apollo being in the like AI generated sales workflows, right? So right now you guys do a lot of automatic generation of like emails. So do you see this like also as a task where you guys could branch out into like orchestrating like sales workflows? And do you see that as a generation task or like more of an orchestration task?
Yeah. One short answer is in real world, it's actually very complicated, right? When people think of the say the LLMs in terms of what they can do, I think there is over indexing in terms of the generative side of things, right? Um, there's like two things that makes these LLMs really good, which is their ability to kind of compress knowledge, right? They store tremendous amount of knowledge, right? They can just compress the entire web corpus, in a matter of GBs, right? So, and then you have your reasoning, right? So these two can be tapped in like very separate ways, right? As I said, right? Essentially, LLMs are going to be the evolution of what databases actually are, right? Databases you do fact in and fact out, right? Whereas with LLMs, you could be doing fact in and you'll be getting insights out, right? So in real world, you would see these like different insights is coming from multiple sources. Again, as I said, right, you just so many do as a sale as an SDR, there are so many actions that actually go in that people actually take it for granted, right? There is research, there is conversations, there's emails, there is trade trace and whatnot. So you're getting all these insights from like multiple different sources and multiple different models, and the beauty is that we could be reasoning in terms of, hey, this is all the insight that I have in terms of all your calls, all your emails, all your success and failures. Hey, now, hey, model God, now tell me, what is the right thing to do at this point, right? So that is the combination which you can actually build an application that is actually going to be successful, right? It's not, say, an application that can just simply generate things. It's like the prompt engineering has a limit, right? One of the very interesting things that we learned when we actually started building the email generation and whatnot is the reason why humans are good at what they do, right? These models are great because humans, by definition, they break the pattern, right? If you look at the best marketeers, they see what the pattern is out there, they break the pattern so that they can get people's attention, right? So that is a converse of say what machine learning actually is. You see patterns, you try to generalize. So when I see what the future of these workflow applications is, you have all these different insights that's coming from multiple sources, then there's going to be this immense power that you get from inferencing that never existed before. It could be actually guiding users in terms of what is the right thing to do at that point in time.
Got it. And do you see like some parts of, let's say, what SDR does on a day-to-day basis? Like, so what parts of that do you see getting automated in the near future, and what parts are not? Would love-
Yeah, so a lot of the mundane stuff are going to get automated for sure, right? So take an example of someone responding to an email saying that, hey, you know what, don't bother me for the next 2 weeks, right? Then now you have your workflow trigger to say, hey, you know what, we can resume this workflow in 2 weeks, right? Like recommendations for leads, right? That is something that's going to be changed immensely, right? Now, all you want is say people to be just giving feedback in terms of hey, these are the account recommendations. Hey, you give feedback or you get automatic feedback. You know what, who is successful versus who is not, right? So that recommendation feedback is going to get very very simple because now we're just looking for say how do you tap the human insight that is not available to say all your data sources and feed that into the workflow. So that is going to be the differentiating factor. So most of the mundane activities in terms of responding to emails, something that's simple, that is all going to be automated, and you're kind of finding, say, the right people across the entire world, right? That is not going to be as laborious as what it is today, right? Essentially, you'll see a world where people say, "This is my ideal customer profile," right? You get 20 people, you say like 200 left right swipe, then you get the next 20 people, right? That's how it's actually going to be, as opposed to people just emailing hundreds of people and seeing who replies and whatnot. So yeah, so I think with an ML AI, okay, I'm still getting used to saying AI. So since I've been in this industry for long, the statistics ML and now it's AI, right? So yeah, with ML, I think you'll see like SDRs like on steroids. So you'll be able to see them, they're more, at least like 50% more successful than what they were before.
Got it. No, that's super interesting, and I think we're all looking forward to that. Yeah. Awesome. So again, back to Prasenjit again. Just wanted to understand, like in terms of like fine tuning, right? Especially like when you have like these constraints of like safety, right? Could you elaborate more on that part? Like how do like people think about safety, like from a strategy point of view? Even like if they're fine tuning the models, what do they need to make sure? Like. So.
Yeah, yeah. So yeah, safety is a good dimension because it's something that's very important to us. The way we started to look at safety was primarily from the point of view. So first is the fact that a response that is generated by the LLM, is it toxic or not, right? That's one part of the safety. Then there are the other parts of safety, for example, that somebody is trying to get an answer. Maybe somebody is, trying to be violent or commit harm to themselves, right? You can ask those questions in various ways for the LLM to, to fool the LLM to actually give you the answer. If you straight away ask that, oh, how can I create a bomb or something, right? Maybe it will say, no, I cannot tell you, but you can say that, oh, what are the different ingredients? You can ask in many different ways, right? That actually can elicit an answer. And kids actually have started becoming good at it, right? You see, they literally can hack ChatGPT to now give answers to things, right? So, and I think they're good testers. I look them as good testers that way. But so safety is, I believe it's going to be a work in progress. It's not going to be ever that we are done, because it's constantly evolving. The way we see how people and because we do a lot of observations with our users, right? And the way we see it is that when we observe something, we go back and start to look at, okay, these are the dimensions of safety that we have addressed, but looks like that doesn't work, right? The other important point, the way we look at safety, is to give the power in the hands of the teachers, right? Because ultimately they are the people who are in that situation when they're when such an interaction with such a system is happening. So what we are doing is also to make it highly configurable, right? The teacher can actually turn off different, set the levels of how they want, right? Versus this whole helpfulness versus harmlessness, right? So you can set those parameters. If teacher is comfortable with that, okay, I'm there, I can intermediate this whole discussion, right? I can let this be a little more fun and engaging, that it says something. Of course, it should not say something toxic anyway, but it can be a little more fun and creative, right? In that sense. And here in the classroom, being creative is a very dangerous word, because it can mean various things to various people, right? It can be racial sensitivities. It could be making a joke about somebody's background, whatever, right? It may sound fun to someone, but it can become pretty serious. It can have pretty serious consequences, right, for others. So for us, we are looking at stochastic based as well as more rule based aspects, right, for safety, because some things you cannot just let the system, the probability decide what should happen or what not, right? So there is the probabilistic part, and then we have the deterministic part also, which and that's why I said, right, that for us the peripherals of that system are much bigger than the model itself, because we are in an industry where all of these aspects, right, especially of safety, is so important.
No, thank you. That's, I think, super helpful, and I think we all want our AIs to be super safe.
Yep.
Yep. Cool. Moving back to Elliot and the last question, and then we'll probably open it up. So just wanted to understand, like, what is the practices that you have been using for deploying machine learning models, right? And like strategies for achieving like cost-efficient inference at scale.
That's for me.
No, this is for Elliot, but again, we
Oh,
can
okay, Elliot. Okay.
take you next. Yeah.
Yeah, so the one thing that's happening right now is that there's a GPU shortage. So on most of the cloud providers that we're using, it's been really, really hard to get our hands on GPUs without making reservations. So for instance, at Photoroom, we used to be auto-scaling throughout the day because the load is uneven. And you could have, let's say, been using, okay, 100 instances in the morning and 200 in the afternoon. And today, for us, this is no longer possible because when we try to scale up, usually in most regions, the cloud providers are telling us, okay, we are at capacity. There's no more GPUs available in this region, which is a big issue because your users are still sending requests and you cannot follow up. So this is the main concern that we have today. Like, how do we manage this scale throughout the day? And today we're always at peak capacity because it's not really easy to auto scale. Now, when it comes to optimizing cost, the best option we found was to really, really thoroughly optimize the models before deploying them. So we use a large range of techniques for this. One of them is making sure that your GPUs are always busy and running at all times, which is not always easy because if you have several instances, distributing the load pretty evenly among all of them is not an easy problem. It's a load balancing problem. It's not really easy. The second thing is that we're using software such as TensorRT from NVIDIA, which allows us to compile the model, merge some operations, and optimize it for the GPU we're running on. So we have to compile the model for all of each GPU, but we've seen gains from 1.5x to sometimes 10x compiling the model. So if you compare the unoptimized PyTorch version and the very well optimized TensorRT version, sometimes we see gains of 10x between the two, which incidentally turns into 10x gain into cost. So it's 10 times cheaper because it's 10x faster. So this is something that we do internally, and we have experts in our team that are optimizing the models using TensorRT, which is sometimes not always easy. The versions are changing. Your models are not always compatible. This is something that we are really still learning on doing. And yeah, those are this will be the main thing that allows us to optimize for cost. And of course, this also happened during research and development, picking the models that will run fast and allow us to optimize the cost. You can play on several things when it comes to image background removal or generation, the resolution, of course, but there are also other factors that you can play when it comes to designing models that will make it faster later when it's running in production.
Got it. No, this is super helpful that we can start as early as like model training, and then we can definitely use a lot of the compilations and optimization. So definitely once we go to scale, I think those are very efficient things to think about, right? No, yeah, I will open this question up for again probably Prasenjit and Saravana also. Any comments you have on like cost per inference and how does that like affect you, and how do you think about models in that way?
You wanna go?
Yeah, okay. Yeah, I mean, something that was very interesting about Hugging Face's presentation is that it's still surprising how quantization is not on by default, right? Something that we're doing at 2018 with Distilbert, right, is not, it's strange to actually see that that's not the default mode in which people operate on, right? So, uh, again, it's scale and cost is not necessarily a, say, the huge priority for, say, in Apple, but sorry, in Apollo, but in Apple, that actually becomes a huge challenge, right? Because you're trying to actually pretty much run models on every single keystroke on Safari and Spotlight. So that's what I was doing before. So there again, just going for, say, models is probably one of the biggest key, right? And you're pre-processing, right, in terms of what you can actually, what do you want to send to the model and what you don't want to send. And of course, we were big users of TensorRT as well in terms of what kind of optimization that we can do. And again, unfortunately, GPU procurement was a big challenge then, and unfortunately continues to be a challenge now as well. I don't think much has changed in the last 4 years. So yeah, I mean, it's again, it goes back to like engineering, right? It's like really really good engineering, and once you have, say, the pipeline, right? Once you have solved the problem, then and you have a repeatable way of actually solving the problem, then getting to a performance state becomes very 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 good, which is why MLOps actually is a huge role to play, right? Once you have the entire pipeline running, then from there optimizing that becomes much more easier. So anyone who's trying to actually look at this problem, which says, hey, you're never going to get it right the first time. This is an iterative process. If you build a pipeline, then boom, right? You can optimize in terms of the quality, performance, and whatnot, and you should be able to swap multiple models and see what actually gives you the best gain ROI in terms of your latency to say your accuracy.
Yeah. Yeah, no, I think Eliot and Saravana has captured almost everything, right? It's an art, so I think we share similar recipes. So, but yeah, exactly. I mean, we are trying all these different aspects, and model size for us is a very important part. And to Saravana's point, right, we are also taking this whole mixture of experts approach, right? So where you have multiple models which are good at a particular task. For example, one could be on question answering, one could be on slide generation, one could be on something else, right? Because what we have found is that if you load a model too much with a lot of different tasks, it starts to break, right? I mean, the whole catastrophic forgetting or whatever you may call it, right, is basically the models, especially the smaller ones, right, are not very good at doing that. And but for us, the cost and throughput, right, is extremely important because these are real-time interactions that are happening in the classroom, and you have like of the order of 300 milliseconds to get back with a response. So.
Got it. Cool. So any questions? We'll just take two questions from the audience before wrapping it up. Yeah, I think first one. Yeah, you can be loud.
Hello.
Yeah.
Thanks for the very insightful session. I had a question to Prasenjit actually, because you have an interesting offering where you also have an edge compute unit dedicated to your product. How do you think about like distributing tasks between the cloud or to the edge, whether it be training or inference? So I was just curious to know what your thoughts are on that.
Yeah, it's a great observation and something. So we started as an edge company with this voice assistant in the classroom, and that's our Symphony classroom, right, that you see there. And right now, the way we are looking at this offering, right, of our LLM-driven products is mostly cloud-driven. But we are actively researching on how the device that we have, because it has a neural processor and all of that, right, in a GPU, how we can use that to actually offload some of that to the edge device. It's still in the experimental stage, but something that we are seriously looking at. But an excellent observation.
Any other questions? Yeah, I think we'll take one from the back. Better than virtual audience.
All right. Again, this is for Prasenjit. So you mentioned how groundedness is really important for you across your solutions, right? So just wondering, since you also mentioned the first go-to-market strategy is building on top of open source, fine-tuning whatsoever, and you put a lot of effort in your data sets, but still hallucination is a problem from where I'm standing, right? So do you do something, especially while training, to counter that hallucination? If not, how do you actually counter hallucination?
Yeah, so there are a couple of levers, right, we are using, right? So one is, of course, the quality of data set, right, definitely helps. Because what we have found from our experimentation, right, that taking any of these, the open source data sets, right, we led to a lot of different issues, right, of hallucination, and it's obvious, right, we are dealing with a very particular kind of content, right. So hence we spend quite a bit of time curating the data sets, the formatting the data sets, all of that, right. The second is, of course, all of us know, right, the temperature part of it, right. I mean, but the third thing, right, which really helped us was the whole retrieval-driven generation, right. The whole retrieving from a corpus and then generating. That was one thing that helped a lot, because now what's happening is that you are not letting the LLM go and suddenly start making connections from here and there. You are really forcing it to say, okay, you need to stay in this particular space, right? So there are a couple of these levers, and I would say the corpus, the retrieval part was actually something that really helped us to improve groundedness. For the others, it still remains slightly, whether you talk about the temperature settings or the any of the probability settings or any of the fine tuning, right? All of that still that leaves things to chance. It definitely improves, but it's still in a probabilistic beast that you are trying to control.
Got it. Cool. Thanks, Prasenjit, for both of the questions. So this concludes our panel discussion. Thank you again, Eliot, Prasenjit, and Saravana for having this insightful discussion. So yeah,
I think since Eliot will be logging off, any like 2-3 questions, maybe if you have the time, we can take. Sure, I'll just give him one, and then I'll come to you.
Eliot, just a quick comment. I love your background segmentation. Your hair, I was just amazed by it. Just wanted to say that.
Thank you.
I think I can.
Yeah. Am I audible? Eliot, you mentioned about using the GPU to the fullest, right? And are there any tips that you can give in terms of like how are you warming up in terms of scaling in, scaling out, as well as how are you queuing your requests, right, to this GPU?
Yes, so in the end, we're using one of the best tools that's available here. It's called a Triton Inference Server, and it's from NVIDIA. And this is one of the most optimized inference tool that you can use. So you give it the list of your models, and it will make sure it's using the GPUs to its fullest. So there are several things that for us it's we're running inference in real time. So we cannot really get 100% of the GPUs because otherwise the latency will be too high. So if you see that your best setting, for instance, is a batch size of 4, you would have to wait for this batch of 4 to be fully there before running the inference. And so for our users, they would be waiting a bit too long. So if you have the luxury of being able to batch the requests, there's a tool that's provided by Triton Inference Server that allows you to figure out what's the best batch size, as well as what is the best number of models that you want to put per GPU, and this gives you the optimal version to run inference. And that's just if you want to run it custom, but of course there are other solutions such as Inferless that allow you to run your inference and not have to think about that. But yeah, I'm talking here about like the custom solution provided by NVIDIA.
Thank you.
yeah. Just to add to that, I think if you want to understand more about like how to use GPUs efficiently, like we'll have a demo at the end, so that will tell you how to like use it in a truly serverless fashion, which is like very similar to your question. Yeah.
One last question we can take. Yeah, can you just pass on?
So as you said, LLMs are quite popular, almost commoditized, I can say. So what is the real moat for an AI startup today? Is that a tough question? Sorry.
Yeah. I guess if I know that I'm starting 3 startups right away.
Yeah, we were looking at who answers first.
Right. Yeah, I mean, the structure that solves a user's problem is going to be complex, right? I think kind of that's the value that you give, right? If you actually put like a thin layer on top of an LLM, then you're going to be disrupted the next day, right? So again, almost any production value useful systems are indeed very, very complex. It's not only hinged on one model that does things really well. So when we're building question answering from web for Siri, the model that actually extracts answers was the first thing that we were able to solve. Right, this is like pre-BERT, bidirectional LS streams and whatnot, and this gave good performance. But to actually make that usable, it took almost another 2 years to actually have that work in a predictable and a safe and consistent way, right? So yeah, so the thing is, if that's, I'd say it's kind of the biggest challenge. It's not just about one model that's going to solve. It's about how do you solve this problem by taking like all this input that come from multiple sources and produce something that's cohesive and say, something that's actually valuable to the user. Of course, I don't think that actually is a helpful answer. So, every problem has its own challenges, but I'd say that's the biggest challenge, and that's the biggest value that you also give to your users.
I think most VCs would say like first mover in the market would give you an edge, right? So maybe like it's just something I was thinking. First mover in the market, capture real world updated data, so you have quality data, and then building accurate AI models and trying to solve customer problems.
Yeah, I mean, first mover advantage definitely helps, right? And we saw that in case of OpenAI, right? Because they had something such a great engineered product, right? I mean, they were able to get all the, you have like in 5 days reaching million users, right? I mean, something unparalleled, right? And the more you get data, you are essentially running that flywheel, right? Which we all talk about. So definitely first mover advantage is important. But I'd like to go back to what Saravana was saying, right? Is that industry specific solutions, right? There's a big moat there in terms of, for example, us, right, being in education, we realize so many things that we would have never understood, never got that insight, right, of using that LLM in our industry if we would have just looked at the published papers and so on. So some of these are really things that we realized, and we are basically building our system, right? And we look at this as a system, take a system view of it, as opposed to that, oh, it's just an LLM or that a part of it, right? So that is, I think, very important, right, to look at. And for us, even when we talk to our customers or the VCs, right, the most important thing is to highlight the fact that it takes a lot of, to Sarana's point, a lot of engineering and a lot of domain knowledge to actually get to where we are, right? From the point that you have even a good quality, well-trained LLM to the point where you're actually delivering great products.
Thank you.
Cool. I think one last question.
Just a general observation, maybe that you guys can give, which is over a period of time, we have seen the inferencing costs being lower and lower and things like that. Do you see some sort of a Moore's law acting equivalent over here so that you can actually predict some of these things and then start planning on having larger models and things like that right away, rather than solving for inferencing right away? Like, do you see any pattern over the last few years of your time?
Eliot, you want to start?
Yeah,
Probably?
maybe Eliot can take that.
Sure. So here we at Fortran we see two trends. One of them is that the compute is indeed getting cheaper with NVIDIA and other providers really releasing more and more powerful chips over the year. And this is roughly following Moore's law in the sense that you do see an increase in compute power for the same cost. The other thing that's happening in parallel is that the models are getting more and more efficient, and the techniques that are used to run them are running also very more and more efficient. This is not for inference, this is for training, but to give you an example, the cost, how much it costs to train a stable diffusion like model went from $500,000 to 50K, and is going down like faster and faster. So you have those two trends of more and more compute that's getting cheaper, and also models that are getting smarter. So the two trends combined are really showing us nice curve of model abilities, and it's really hard to predict how fast it will go. Will it go faster? But you can certainly bet on it when you start a startup, saying, okay, the model I'm working on right now, probably in 6 months, is going to be even more powerful for the same amount of money.
No, that's very helpful. Anything you want to add? No, no, no.
Yeah, I
Okay.
think that's probably the
Yeah.
best response.
Yeah, no, I think that's
Yeah.
a really great response. So I think, yeah, in terms of like machine learning, I think definitely Moore's law is like still like applicable. So every day, like I think in CPU we have hit the limits, but in GPU it's still wide open. Yeah. Cool guys. So I think that's it. We have some snacks. I think post that we'll like resume the next sessions. Thanks so much, Eliot, for joining us.